Assalamu alaikum wa rahmatullah. I welcome you all to the 14th video. Here is where we stopped, and example 3.5. We're going to start with example 3.5. A body of mass 100 kilogram is released from a height of 200 meters. With what energy does the body strike the ground? Okay, okay. The body has this mass, and then it falls from a height of this. Okay, the energy should be mgh. Don't forget that. M is the mass and is given. G is also given. Height is this. So you multiply all the three quantities given: mgh, mass times g, acceleration times height given, and this will give you 200,000 joules. And then you divide by 1,000, you will get 200, and dividing by 1,000 will change the joule to kilojoule. This is all converted to kinetic energy because it's potential energy, and it's all converted to the potential energy by the time the body strikes the ground. Okay, kinetic energy we say is the energy due to motion. If a body has, okay, in the formula for kinetic energy we have half mv squared. So it means it depends on mass and velocity. A body with high mass, very large mass, even if it moves slowly, because of the large mass it has, the magnitude of kinetic energy is also large. Okay, a small mass will have to move fast to acquire high velocity, so that its kinetic energy should be very high and its impact should or will also be very high. Such as a bullet. A bullet has a small mass, but when fired, it moves with a great speed, and that is why it has significant, dangerous impact on the target. Okay, masses such as uh, lorries or tankers, big masses. Even if they move slowly, because their masses are huge, even if they move slowly, the kinetic energy is great. Okay. Here is an idea they used to derive kinetic energy. The formula for kinetic energy from work done. Work done equals force times distance. So force is F, distance is S. But then from equations of uniformly accelerated motion, we know that S is equal to average speed times time. Let's say a body starts from rest and its velocity increases from 0 to V. This is the initial velocity, this is the final velocity. We can take the average of this velocity, initial plus final, divided by 2, and then we multiply by time. This will give you the distance covered by the body. So 0 plus v will be v, v times t will be vt, so it means you have half vt. And then the force from Newton's second law is ma, and then we know that a is velocity over time, so it means mv over t. So if we substitute this into this, that our force is mv over t, and our s is half vt, then look at what the work done will become. The work done will be half vt for the s, and then for the force it will be mvt over t. So t will cancel t, and from here we have half, and then we have v, and v here will be v squared. That's why we have half mv squared. So kinetic energy is half mv squared, proven from the formula for work done. Okay. Okay, here is an interesting example. They say a boy of mass 30 kilogram is running with a speed of 4 meters per second. What is his kinetic energy? Now we use the formula kinetic energy is half mv squared. So m should be the mass of the boy, v will be the velocity of the boy. So m is 30, okay, v is 4, so we square the 4. So we take our calculator, 0.5 times 30 times 4 squared, we will get 240 in joules. Okay, here is the next example. A bullet of mass 40 gram is moving with a speed of 216 kilometers per hour. Wow, wow, wow. This is a very large speed, very great speed. Calculate its kinetic energy. Okay, look at this. the mass of the bullet is not in SI unit. You have to divide it by 1,000. This one is in kilometer per hour. We must change it to meter per second, and this is how you do it. For the mass, 4 gram, divide it by 1,000 and you will get 0.04 in kilogram. Now for this one, the kilometer, to change kilometer to meter, you must multiply it by 1,000. That is why you see times 1,000 here. Then you divide by the hour. 1 hour, to change it to minute, you multiply it by 60. To change it to second, you multiply by another 60. So it means the value you have, multiply it by 1,000, and by that you are changing kilometer to meter, and then you divide by 60 times 60, you are changing hour to second. And then when you do that in your calculator, you will get 60 in meters per second. Then you will now use these two values that you just got in your formula. So kinetic energy is half mv squared. Your mass is 0.04, so use it here. Your v is this 60, use it here. So take your calculator, press 0.5 for the half times 0.04 times 60 squared, and you will get 72 joules. Interesting. Okay, let's see the next one. Oh, here they are trying to explain conservation law of mechanical energy, meaning, okay, alarm off. Okay, conservation law of mechanical energy. The total mechanical energy of a system is constant. That's the law. Look at it here. Kinetic energy plus potential energy is a constant. Or at any point, the total kinetic energy and potential energy at any point equals the total kinetic energy and potential energy at another point. And here is they use simple pendulum to explain that. Okay, this is the equilibrium position of the simple pendulum. Let me also use it to explain it here. Point C here is the equilibrium position. If you push it to point A, as it moves to point A, its velocity is decreasing. When it reaches A, it has zero velocity, so the kinetic energy is zero here. But then you have raised it to a height h, so it will have a potential energy mgh, and this potential energy is maximum, and then the kinetic energy here is minimum. It is zero. That's the minimum, because the velocity here is zero. Then it will come back. This potential energy that it has acquired will now be converted slowly to kinetic energy as it is coming back. When it comes back to C, it will have the maximum speed, maximum velocity, and then the h now will be zero, because as it is coming back, this h will be reducing. At C, no h. So at C, potential energy is zero and kinetic energy is maximum, meaning all the potential energy that it has acquired here is converted to kinetic energy here. But at this point, any point you touch here, the total, let's say this is a point here, and I get the potential energy here, the kinetic energy here, I add them together. If I come to another point somewhere here and I get the kinetic energy there, the potential energy there, the total will be the same total I have here. And this is true for all the positions here, Okay, when it passes here and reaches B, again as it moves towards B, the velocity will be reducing, so it will be converting its kinetic energy to potential energy, because the height here will be increasing. At B, all the kinetic energy is converted to potential energy again, and it will have zero velocity, zero kinetic energy here, with uh, maximum potential energy mgh. And this is why we can use it to get the value of the maximum potential energy, maximum velocity, because maximum potential energy mgh is equal to maximum kinetic energy half mv squared. V here sub maximum. So here m will cancel m, and you bring 2 here to get 2gh. Then divide both, take the square root of both sides, and you can get the maximum velocity v equals square root of 2gh.